One thing we can do in QL is to construct models for particular purposes. So here there's a problem set where for each sentence of QL we want to construct a model in which that sentence is true. Now I'm making this video in Carnap so that you can see how the Carnap interface works in constructing models, because it's a bit different than the standard notation that's used in the book and the notation that I've used in the slides. Two things to note about Carnap. First, it only allows numerals, that is numbers, to be members of your universe of discourse. So you can have a universe of discourse like 3, 4, 5, but not one like Giles, Xander, and Willow. You can't have cities or continents or people or pets. You can only have numbers. And for reasons I explained in the earlier video, that doesn't actually lose us anything, because we can have things that are formally equivalent. We can let numbers stand in for whatever objects we wanted to talk about. And it's just an ease of interface thing. The Carnap can check the problems more easily if they're put in terms of numbers. And this is also something mathematicians do a lot when building models. Second, Carnap doesn't require the curly braces that we put around sets. So you don't actually have to write them in. All you have to do is to indicate the universe of discourse or the extension of a predicate is to write the objects, the numbers, separated by commas. And as always, even after Carnap checks your answers, click Submit so that you get credit for your work. Okay, so the first problem in this problem set, the one I've got as a sample, is this here, P, F, and PG. So Carnap suggests we start out with a domain that contains 0. It doesn't have to be 0, it could be anything. I'm going to let the domain be just contain the number 6. Now, what should the extension of the predicate P be? Well, if we put in 6, and now Carnap also suggested we have the referent of F be 0. Well, it can't be 0 if our domain contains 6. Our domain doesn't contain 0. So we have to put in something that's in our domain. So here's a model. The referent of F is 6. 6 is in the extension of P, so PF is true. 6 is the referent of G. It's in the extension of P, so PG is true. And that's going to make the whole thing true. We check. Carnap agrees. Success. Okay. So here's a simpler one, or a different one. The second problem is for all x, fx. I'll take Carnap's suggestion for a domain here and try out the domain 0 that just contains 0. I need an extension for f. If we put 0 in the extension of f, then it's true that everything in the universe of discourse is in the extension of f. Again, great. This one's a little trickier. Looking at problem 3, we've got a more complicated sentence. Exists x mx. So we have to have something in the domain, in the universe of discourse, that's in the extension of m. But now it needs to and it is not the case that for all x mx. So we can't make it the case that everything in the universe of discourse is in the extension of m. So we need to put something else in the universe of discourse. Here, I'm going to put the numeral 7. So our universe of discourse is 0 and 7. Extension of m contains 0. So exists x mx is going to come out true because there's something which we could plug in to make mx satisfied. But it's not the case that all x mx. Success. So the key to this one was that we needed two things in the universe of discourse, in the domain, and we couldn't put both of them in the extension of m. We could have more things, but this model works. This model shows that this sentence can come out true. Here's a fourth example. Exists x rx a. Okay, one object in the domain. I'm going to go with the number 4. Referent of a is going to be 4. Now, we want there to be something such that Rxa is satisfied. Well, remember, and the trick for this one is, for a two-place predicate, we have to have pairs in its extension. If I just try to write for, Carnap already throws up this little warning sign here. It says, couldn't read the relation specification for R. Unexpected input, expecting digit, blah, blah, blah. It accepts only tuples. Tuples, where it says two tuples, that means pairs. Carnap is reminding us we need a pair here. So let's put in the pair of 4, 4. So 4, 4 is in the extension of R. So there is something such that we could put it in for XA to make Rxa satisfied. So exists Rxa is true. Carnap agrees. Success. So this is a kind of problem we'll be doing more of next week. I've given you a problem set that runs from pretty easy ones to sort of middling hard ones, and you can try them out and see how you do. If you have questions, of course, come by office hours or come by the study session or ask on the forum.